Okay, so this is approximately where we left off with last time. So why is it that why would you think that organisms probably would have a hard time living in fresh water if they originated in seawater? Why would that be a tough transition? Think about that for just a moment. So we're talking about this point right here. So why might that be tough to be living in seawater, then all of a sudden try to live in, as you can see, fresh water? What's the fresh water missing that seawater has? Salt. And for those of you who remember 1 and 2 years ago, what are your four movements across the cell membrane? Well, there was diffusion, there was active transport, there was facilitated diffusion, but then that fourth one was what? Starts with this. Osmosis. That's why you people put the books underneath your pillow, right? So that osmosis flows right into your brain, right? Or is that just a California thing? You don't do that? Oh, okay, that's probably a good thing to do then. All right. So, notice this heading is ecological relationships. Many animals live as parasites in or on sponges. There's got to be a reason that these animals would do that. So, why is it that parasites might kind of want to hang around in these sponges? Well, as we look at this, okay, these are very distasteful then, as you can see, very distasteful substances or even toxic to some of their predators. So that's why they kind of hang out inside of these sponges then. So one of the things that we will talk about next chapter, and kind of what would a symbiotic relationship be? We're talking about something like this, an ecological relationship or a symbiotic type. What do you think a symbiotic relationship is? So let's see here. Out of yourself, 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 or yourself. So when I pointed to those four, because you're a lineman, you don't count. You're a lineman, you don't count. So when you're a lineman, you don't count. Notice I didn't point at Nate yet. Okay? So, in other words, could be such a thing that, holy cow, you pick up the game stats and Nate Tolley from Coleman Egan, 350 yards passing. Well, holy cow, he's only throwing these little 5-yard passes. That's a lot of throws. But who can we pick on of you four? So what happens is you're only catching that ball 5 years. Well, maybe 5 years from now. 5 yards across the line of scrimmage. But he's got 350 yards. Who's doing all the work here? Really? So, but my point is, he's throwing it to you 5 years. I said it again. 5 yards across the line of scrimmage. So how's he getting 350 yards unless he has 100 passes? You're doing all the work. Makes him look pretty good. But you also can't get all them yards unless he gets the ball too. Maybe he had to do some scrambling. See, sometimes you can raise your hand and say, pick on me because it might be good news. Right? Yeah. So pat yourself on the back, Riker. Making Nate look good. So, Nate, you should pat him on the back too. Okay, he's fine. All right. So that's what we mean by a symbiotic relationship where two will benefit from each other. Just the idea of Nate is benefiting from Riker's smooth moves and getting open, but in order for him to get the ball, maybe he had to do some scrambling. So again, it's somewhere you benefit from one another. In this case, so the sponge really probably isn't benefiting from this, but probably a type of asexual reproduction to where you can make another colony through, again, you don't have to have that type of egg and a zygote come together. So it's spreading the colonial mass, if you want to call it that, or the reef structure. So they benefit from one another. All right. This is important here because, again, what are some characteristics of sponges? They're porous. There should be 4 of them or so. They can't move, so they're sessile. Another term is up here. They all have an osculum. They might be kind of hungry too, maybe like you individuals. They're filter feeders. That's right. So what we're talking about here, this osculum, that's an opening up on the top of sponges. Now, other than leuconoids, they would have multiple ones of these because those are the largest types, okay? But otherwise, the asconoids and the cycanoids are simple sponges that would just have one osculum, okay? So that's why we say one or more large openings on the tops or sides of sponges for water outlet. Now, when it says water outlet here, before it got that far, there must have been something that came inside the sponge that then got filtered. That would be just organic debris, algae, or something to that effect, because that's what they would be feeding upon. Okay. Let's see here. I want to do this one and that. So this will be the last one for today. So a lot of these terms that you see, not only are you going to have this in a diagram, but you'll probably see this tomorrow in your vocab quiz, okay? So keep that in mind. Yes, that is tomorrow, and we'll proceed moving forward from there. Follow college or professional football then, either one, or well, you might have told me that, but now this is one of them things where I'm not looking back and saying that's what he should have done. come on, it's first and goal. I honestly thought when he threw that, he was throwing it away. Yep. Yep. That's one of the things that in many sports, okay, especially when you get further into the season, when you're playing good teams, you know, the mistakes, they kind of amplify themselves. And of course, that was a very critical one because the loss was bad enough, but what compounds this loss? Think about it. This is where, you know, we're not just thinking here in class, but think about why this loss was catastrophic. Why would it be if they played the Giants and lost? Okay, that stinks. Or they played the 49ers and lost, or any other team. But why is it catastrophic to have this loss? It's in their division. That's right. And that kind of stinks. Okay, so we'll pick up with this next time.